All right, so here's the first question you asked. This is number 16. So it says an airplane needs to head due north, but there's a wind blowing from the southwest. So let's draw the north that we want to go. So that's the north that we want to go, and it says the wind is blowing from the southwest. So I'm going to draw the wind next and pointing to where we want to go. So the wind is going that way. The plane that we want to go that way. So then the pilot needs to point a little to the west of north. Okay, and so this is, we'll say, call the one going straight up, we'll call that H for heading. The one going, then I'm going to say W for wind, maybe P for the direction the plane is pointing. All right, so let's see here. So the wind is going 80 miles per hour, 80 kilometers per hour, sorry. So I'm going to write 80 up there for the length of that side. And then the plane flies at an airspeed of 600 kilometers per hour. So I'm going to put an 600 on the left. And it needs to head due north. All right, so what we've got here, we got a, let's see here. Let's see here. Sorry, trying to momentarily. Oh, the wind is blowing from the southwest. That's what I needed. So wind blowing from the southwest means the angle at the top right is 45 degrees. Hold on one second. I'm going to pause this for a second. All right, sorry, I had some yelling children in the background. All right, so now with this, the angle I have is opposite a known side. So I'm going to use the law of sines. I always prefer to use the law of sines if I can. And what I'm going to do is use that law of sines to find the angle at the bottom of this triangle, which is actually the answer that I want for the first question. So let's see, since I have an angle with the law of sines, you can either put the sines on top or you can put the lengths of the sides on top. I always put the unknown thing, I'm going to call it sine of A, over the length of its opposite side, 80, equals the sine of 45 degrees over the length of its opposite side of 600. So the solution to the sine will just be 80 times the sine of 45 degrees over 600. Now, sine of 45 degrees is exact, but that doesn't matter because I'm going to get an approximate answer in the end anyways, because A is going to be equal to the sine inverse of all of that. So 80 times the sine of 45 degrees over 600. Oop, one too many zeros. All right, and then I need to type that into my calculator. Let's see here. Oh, it's going to make me type it. All right. There it goes. Okay. As soon as that pops up, that'll give us the answer for A. Okay, and I think from last week it should still be in degree mode. Let's just check real quick. Nope, it's in radian mode, so I'm glad I double checked. Put it into degree mode. All right, so I'll do the inside first. I'll say 80 times the sine of 45 divided by 600. So that will be 0.094. Then I'll do the sine inverse of that. And so I get about 5.41 degrees. And it says the nearest tenth of a degree, so 5.4 degrees. All right, so if I put that, oops, I'm on the wrong page to put that in. Okay, so that's 5.4 degrees. And I think that's going to be, that was to the west of north to counteract the wind coming from the west. We need our plane to point west. Now I need the length of side h for the ground speed of the plane. And so what I'm going to do, I'm going to take that 5.4 degrees, and then I'm going to find the angle opposite side h, and I can just do that. Well, actually, I should call, let me call the heading lowercase h, because usually we use capital letters for angles. So I'm going to say angle h is 180 degrees, minus 45 degrees, and also minus 5.4 degrees. So that'll be, let's see, minus 45 would be 135. So that'd be 120.6 degrees. And now I can do the law of sines to find side h, but this time it's a side I want that's unknown. So I'm going to put h on top over the sine of the opposite side, 120.6 degrees. Will be equal to, and I'll do the one I know exactly, 600 over sine of 45 degrees.
129.6, you mean?
Oh, yeah, sorry, 129.6. Geez, yeah. That's what I meant. Thank you. Right, because 135 minus 5 is 130, minus another 0.4 would be 129.6. So then I multiply by that sine of 129.6 degrees, and that will give me my answer. So you see, even though this is in the vector section and you could solve it using vectors, it doesn't really make sense to, because it would make it, to find the actual component forms of each of those vectors would actually be more challenging. So let's see, I'm going to do 600 times sine of 129.6. Oops, 120. All right, that looks good. Divided by sine of 45. Hit enter. So 653.8. Looking at the picture, that makes sense. 653.8 miles per hour, or kilometers per hour. It says round to the nearest, so that'd be 654. So let's go back. So 654, and then we'll submit, and that works out okay. All right. Was that one all right, Richard?
Yes.
Okay.
That was good.
Okay. Now let's take a look at 17. So I'll put this one in my notes too. Do that right. Good. Okay. Oop. Put it way up at the top. Move it. All right. Okay, so this is our next one. It's about a helicopter going different directions. So again, in theory, we could do this with vectors, but we're not going to. So it says, so we're going to start off, it takes off at headquarters, let's make a point, and flies 85 kilometers at 10 degrees south of west. Okay, so that's our angle. The top line is due west. There it drops some relief supplies and flies 125 kilometers at 60 degrees west of north. So if I make a line west of north and go that way, it goes 125 kilometers, and that angle is 60 degrees. Obviously, these angles are not to scale. All right, but what I know is if I continued each of these lines that I drew, the north and the west line, those would form a 90 degree angle. So I know the other side from that 60 degrees has to be 80 degrees. So now I know the bottom angle, and I actually know an angle and two sides of the triangle, and that's all I'll need. Then it says if the helicopter heads directly back to headquarters, find the distance and direction it should fly. So let's draw a line back to headquarters. And the distance I can use law of sines for. The total angle at the bottom is 140 degrees. So call it D. So D, oh, I can't use the law of sine, sorry. Because I need a side opposite an angle and a side opposite each other where I know both of them. So I actually can't do the law of sines here. I have to use law of cosines. All right, so that one would say d squared equals one side squared equals the sum of the squares of the other two sides. Oh, I wrote 85 degrees instead of 85 squared. Wrong superscript. Then minus, so it starts off looking a little like the Pythagorean theorem, but then it's minus 2 times the product of the other two sides times, let me make that look a little neater, times the cosine of the opposite angle, so cosine of 140 degrees. All right, so let's see here. So 125 squared plus 85 squared minus 2 times 125 times 85 times cosine of 140. Hit enter. But that's d squared. So now I need the square root of that. So I'm going to do square root of the answer and enter. So 197.8 kilometers, roughly. And it says 1 decimal place, so that's good, 197.8. Let's go back and put that in. 197.8. All right, and then now I need to find the direction. All right, so I know if I draw a line straight up, that the total angle there is basically, that's parallel to the other north line. So if I subtract from 180, I know 60 degrees from 180, I know that total angle is 120. So if I find the inside, didn't mean to move it. If I find the inside angle, I can subtract that from 120, let's see, or from 90, I guess, and get my degrees. Let's see, I think we're going to want to go. Let's see what that says. Oops. I'm on the wrong screen. Let's see. I don't know yet. We'll see. It's going to either be north or south of east, but I think it's going to be a little south of east, but let's see. All right, so let's find that interior angle. So that's opposite the side of length 85. So sine of A, we'll call it over 85, equals, and then we'll do D 197.8 over, oops, that's going to be on the bottom. The sine goes on the top. Sine of 140 degrees over 197.8. Sorry, the opposite side of the 140 degree angle at the bottom. All right, so we multiply by 85. Sine of A equals 85. Sine of 140 degrees over 197.8. Now let's pop that in the calculator and then take the inverse sine. So we got 85 times sine of 140. And we're going to divide that by 197.8. Hit enter. And then do the inverse sine of that. So I get about 16.0 degrees. So A is about 16.0 degrees. So this is 16.0 degrees. Okay. All right, so let's see here. If I subtract that from 180, I'm still not, so like if that's east, then I got 90 degrees above and 30 degrees below it. So I got 90 degrees up here, and then 30 degrees there. So if I do 30 degrees minus the 16 degrees, I get that it's going to be 14.0 degrees south of east. So let's see if that's one of my choices there. South of east, yep. And I think we said 14, is it 14 or 16? 14 degrees. And we'll submit. And that's correct. And you'll notice that it doesn't care if you don't. It says rounded to one decimal place. You don't have to put the 0.0. So. Oh, there we go. So this one is definitely more complicated because you got partial angles inside the triangle. You got to, I continued the east and the north line to make a right triangle to help me find angles. So, and this is more tricky than, there's nothing on the test that's has this degree of difficulty for sure.
Okay, how did we get the 14 from the 16?
Okay,
so 30.
So what I did, I got the 100. First of all, I did the 140 degrees, and that came not 120 degrees because that came. So if let's draw the just the left part of the triangle over there. So when the helicopter went on the second leg, it went 60 degrees west of north. So that's where that 60-degree angle is. So if I go up, I know by parallel lines, if I continued, this would have been a 60-degree angle here, which makes this angle just below that 120 degrees. Okay. Once I knew that the angle in the triangle was 16 degrees, what I could do is draw an east line. And I knew the east line to that would be 30 degrees because the north to east is a 90-degree angle. And then the 16-degree line means it's pointed down below, it's below that, back to the start, the headquarters. So if I had a 16-degree angle there and a 30-degree angle total from east down to my original line, then that leaves a 14-degree angle to add to the 30-degree angles. So I subtracted the 16 degrees from the 30 degrees. And the 30 degrees is because the total angle was 120 degrees, and 90 degrees of that was from north down to east.
Okay.
So
okay, I think I get that now.
Yeah, and so honestly, it could be argued that maybe this one is one that would be easier to do with vectors. So, and I mean, I can even show you what we would do if we were going to do this with vectors. Let me make a second copy of this. Let's see here. Copy. Oops. Oh, there we go. Because if we did it as vectors, basically, so the first one, it flies 85 kilometers at 10 degrees south of west. So if you think of vectors, south of west is this way. So that first vector, this angle is 10 degrees. Its total angle would then be 190 degrees, 180 plus 10. And the length is 85. So its components, its horizontal component, or A, is 85 has a cosine of 190 degrees, and its vertical component is 85 times the sine of 190 degrees. Now, let's pretend that the second line doesn't start from the first line. Let's just look at it as a vector all by itself. It's 125 kilometers at 60 degrees west of north. So let's draw. So that would put a 60-degree angle there, and that length of that vector is 125. So the total angle of the vector is 150 if I add 90 to 90 to 60. So let's actually call it A1, B1. So now A2, B2 would be 125 cosine of 150 degrees and 125 sine of 150 degrees. All right, now if I add those two vectors together, that would put me at the endpoint. If I had thought of starting from the origin, it would put me at the endpoint of the last side. So let's see here. So basically we went this way and then we went this way. So this vector, that top vector, would be the sum of the first two vectors. And then so you can see that you would just negate it to get the vector that would take you back to the start. So if you just did call this vector C equals, let's make that more vector-like, A1 plus A2, comma, B1 plus B2. And then you would find the length of it by doing the Pythagorean theorem. And then you would find the direction. You could find the direction of the vector, which is this, and then you could figure out this angle relative to east, which is by parallel lines the same angle that should be south of east. So, or actually that angle is with west, but it's the same idea. So that's how you would do it with vectors. And maybe the first one was definitely, I think, easier to do. Well, definitely, I think that's not a very definitive answer. I think the first one was easier to do with as a triangle. This one may be more of a wash, whether it's easier to do with a triangle or with vectors.
No, I agree with about that first one.
Yeah.
Way easier as a triangle.
Yeah. But yeah, so that's the idea of how you would do this one with vectors. So when you add the first two vectors, it basically ends up with what would the vector that would be the same as just flying straight to the second point. So for when you for the actual vector you want, then you would then do -1 times c, which would of course multiply. You'd want is the vector you really want because you want to fly in the reverse direction of c, which is just -1 times c. All right.
Yes, sir. Thank
you. Yeah, you might have to go through and try that a couple more times, but fortunately you got the whole week to do it. So
that is true. I think I will have to practice that a little more.
Are there any others that you had questions on, or was it just those two?
Those are the only two I haven't answered yet.
Okay, awesome, good deal. All right, well, like usual, I'll stick around for the remainder of the time.
Okay, thank you.
You bet.